Hi, my name is Josiah, and I've spent the past week or so working on a project that uses a non-invasive brain-computer interface to be able to predict directional thought. So an EEG, or electroencephalogram, is a device that's able to capture the electrical signals from the brain and produce them in a manner that we can use to analyze. The device that was used in this case had 16 sensors. You can see it in the lower right-hand corner, and those were placed on the head in similar to the upper right-hand corner. So part of the reason for this is there's 5 million Americans living with various level of paralysis throughout the U.S. And one of the examples I like to use is Stephen Hawking. And he had a decreased ability to input or output information. If we were able to accentuate that and make it faster, make it more seamless, then there's no telling how much more he may have been able to contribute to the world of science, let alone the relationships that he had. So the data used here was coming from a single subject. There were about 1,200 EKGs that were sampled over for 10 seconds at a rate of 25 hertz. That information was passed through an FFT, and then the microvoltages from each one of those was pulled, and that was the data that was used to build the models. So when doing EDA, it was rather apparent that there are some differences that you would be able to identify between left, none, and right thought. You can see the blue is higher than sensor 7, the blue is higher than green, but significantly less than orange. So that was the signal that I was trying to pull out to build models off of. Tried a plethora of different models. CNNs ended up working best, but I did have a lot of overfitting. You can see some of the other models that we used and the structure of the model that I ended up being the best performing. To combat the overfitting, I used a few different tricks. I tried to decrease the number of layers that were used, add more dropout layers, reduce the number of nodes, and do some regularization as well. It started to work, but it was still not great. So if you see from the upper left-hand corner, the lower right-hand corner, those are the accuracy of the times that I was correctly able to predict what action was thought. The overall accuracy was 0.492. That is significantly better than baseline, just not phenomenal. And then here you can see a quick UI that I spun up to be able to show the differences and when it's right, when it's wrong, and so you can get a sense of how well this is able to predict what somebody's thinking. So the major steps is I need to get more data, a lot more data, preferably from diverse users to make sure that it's generalizable to a large audience. I also need to train for longer. That is particularly on more powerful machines, and then preferably if I can get access to the raw EEG data, that would give me much more optionality rather than just having the FFT data. You can find me on GitHub and LinkedIn. I'm open to any questions. Thank you.